Okay, so for this unit on special right triangles, there's kind of three components of it. There's just basic Pythagorean theorem, which you guys all learned is, the leg squared plus the leg squared equals the hypotenuse squared. So usually these are labeled A, B, and C, but don't get confused because really what you're solving is you want to make sure it's the leg squared plus the leg squared equals the hypotenuse squared. So you really need to be careful and say, well, am I solving for a leg or am I solving for the hypotenuse? So you can figure that out by always finding the hypotenuse that has to be across from the right angle, which is of course noted by the little box. So in this case, I'm given one leg and the hypotenuse, so I need to set up the problem as the leg squared plus the leg squared, which would be x in this case, I don't know what that is equal to the hypotenuse squared. And then I'm going to solve for x. So x squared equals 21. And then I need to take the square root of 21. Always check to see if you can simplify your answer. We can't simplify this, but on a lot of the problems, as you'll see on the review, you would need to simplify the radical further. And then we have two kinds of special right triangles, what we call special right triangles. And that just means that they have a pattern that they always follow. So if it's a 45, 45, 90 triangle, that means that I have two congruent legs. It's an isosceles right triangle. And the relationship every single time is that if my leg is equal to the other leg, then the hypotenuse is going to equal that leg times the square root of 2 every single time. So in this case, again, you have to be careful what you're solving for. In this case, I'm given one leg. The little tick mark here tells me the other leg has to be congruent, so that's also 6. And then the hypotenuse is just the leg times root 2, so 6 root 2. So they can either show you that the two legs are congruent and it's a 45, 45, 90 triangle by giving you these tick marks, or it could actually be noted in the angle itself that it's 45 degrees, right? So if these are congruent and it's a right triangle, these two angles must be equal, therefore they must be 45 degrees because all the angles in a triangle add up to 180. Okay, and then the last type of special right triangle is the 30, 60, 90 triangle. And so that means we have one angle that's 90 degrees, one angle that's 30, and one angle that's 60. So remember that the short leg of your triangle has to be across from the smallest angle. So find your 30-degree angle, then across from that will be the short leg. The long leg has to be across from the 60 degrees, and the hypotenuse is always across from the 90 degrees. So find your 30-degree angle first, then find the short leg, 60-degree angle across from the long leg, and the hypotenuse across from the 90-degree angle. And then the relationship, once I find that short leg, the long leg is always equal to the short leg times the square root of 3, and the hypotenuse is always equal to the short leg times 2. So that's why I say whatever you are given in the problem, always work your way back to find the short leg first and then go from there. So in this problem, they give you the short leg because it's across from 30 degrees. So that's pretty easy. I need to just remember my patterns, right? So 2 is the short leg, A is the long leg, and B is the hypotenuse. So to find A, it's just the short leg times root 3, 2 root 3. And to find the hypotenuse, it's just the short leg times 2. So 2 times 2 is 4. This problem is also a 30, 60, 90 problem, but it's a little more complicated because they're giving us the long leg. So I need to find the short leg first, and then use the short leg to find the hypotenuse. So I have the long leg, that means I have to divide by the square root of 3 to get back to the long leg, because the long leg is equal to the short leg times root 3. So I could set it up with 8 is equal to a root 3, and then solve for a. So I take 8 divided by root 3. I can't leave a radical in the denominator, so I have to rationalize that. So the way I do that is I multiply the top and the bottom by the square root of 3 over the square root of 3. So 8 times root 3 on the top, so 8 root 3, all over root 3 times root 3 is just 3. So 8 root 3 over 3. That's the short leg. And then I want to work from the short leg and find the hypotenuse. So 8 root 3 times 2, I just take 8 times 2, I get 16. So 16 root 3 over 3 is the hypotenuse. So all of the problems work pretty much the same way using all of these rules and these patterns. You just have to make sure and set up your problem correctly, and you need to memorize what these patterns are. So here's a little practice quiz that covers all the topics. You want to always make sure, obviously, read the directions, but it says we're doing exact answers only. So that means I can only leave my answer as a simplified radical. So no decimal answers, all right? So these first 4, these are really just practice and review for what you'll need to do for the other problems that you'll have on the quiz. So the first 4 are just different problems with simplifying radicals. So when I simplify a radical, if I look at this first problem, I have 2 times the square root of 150. So what I need to do is break down this radical into its factors. So I can do that by just dividing by whatever. In this case, it ends in 0, so I can divide by 10. And I get 15 times 10. I could have also divided by 2 since it's an even number. And so I have 15 times 10, and then I want to keep breaking it down into its prime factors. So I have 3 times 5, and I have 10 is 5 times 2. So once I find a pair, in this case I have a pair of 5s, I can take that 5 out of the radical, and then I'm left with 3 times 2. So 3 times 2 is 6. And then don't forget, we had this 2 out at the front at the beginning. So I have 2 times 5 times 6. So my answer here would be 10 root 6. Okay, and when I'm doing, when I'm adding and subtracting, I'm doing the same thing. The first thing I have to do, I can only add radicals that have the same number under the radical. So you think of it as like a variable. So first I have to break down the radical into its prime factors. So in this case, square root of 24, that's 2 times 12. I can break that down further and say, okay, that's 2 times 6, and then 6 is 2 times 3. So when I take out the pair, square root of 24 simplifies to 2, and then I'm still left with a 2 and a 3. So I get 2 root 6 under the radical, and I had a negative 3 out there to begin with, so we can't forget about that guy. Should have given myself more space here. So negative 3 times 2 root 6, so that this becomes negative 6 root 6. Okay, and then I'm going to go up to the next one. I can't simplify that one, negative 3 root 5. So this one's going to stay as it is. And then 2 root 20, you probably know the square root of 20, what that simplifies to now. But I have 4 times 5, and then 4 obviously is 2 times 2. And so I end up with 2 times 2 times 5. So I can take out a 2. And I'm left with a 5. And I had this 2 to begin with. So 2 times 2 times 5. And of course I need to pay attention to what the sign was up here. So that would be a plus 4 root 5. So I'm just multiplying these two numbers and I'm left with the radical. So then I need to combine these together. So I end up with the negative 6 root 6 plus 4 root 5, and then I had this minus 3 root 5 up at the top. So I can only combine the like terms. So I can only combine these. So I'm going to end up with negative 6 root 6, and then 4 minus 3, so I just get 1, positive 1. And you don't have to show the 1. So in my final answer, I end up with negative 6 root 6 plus the square root of 5. When we're multiplying radicals, remember you're going to multiply the whole numbers and then multiply the radicals, what's under the radical. So 2 times negative 5, I get negative 10, and then 3 times 2, both under the radical, so I get square root of 6. And then if I needed to, square root of 6 doesn't simplify anymore, so that's just my final answer. You want to always look and see if you can simplify the radical further, but in this case we can't. Okay, and then lastly, when we have a radical in the denominator, remember you cannot leave a radical in the denominator. I always say no rats in the basement. So to get rid of that, we have to rationalize it. So I need to multiply the top and the bottom of my fraction by just the radical that's in the denominator. So I'm going to multiply times square root of 2 over square root of 2. And so I'm just going to multiply my radicals, what's under the radical together. So I get 5 root 6 all over. And then my radicals, 2 and 2, I get square root of 4. So the whole purpose of doing this is that when I multiply the radical 2 times radical 2, the radical goes away. So I end up with 4 times 2, which is just 8. So I get 5 root 6 all over 8. So that first part was just meant to be kind of a review of skills that you need for this unit. I'm not sure you'll actually be quizzed on these, but you need to know how to do all of that. And then this next section where it just says find the missing side of each triangle, leave your answer in simplest radical form. These are all right triangles. There are no angles, so they are not special right triangles. They're just right triangles. So don't forget you have the Pythagorean theorem that you can use to solve these, right? So in this case, I'm finding the hypotenuse because it's across from the right angle. So this one is pretty straightforward. I'm just going to set it up with a squared plus b squared equals c squared, or the leg squared plus the leg squared equals the hypotenuse squared, right? So I get 9 plus 4. There we go. And that's it. But be careful when, I can always find the hypotenuse first because it's across from the right angle. So in this case, I'm solving for x, which is a leg. So on this problem, I need to set up my equation with the Pythagorean theorem, and then I'm going to solve for x. Okay, so x squared equals 40, so x is the square root of 40. And this is one of those situations where I know I need to simplify it. So 40 is 4 times 10, 4 is 2 times 2 times 10, 2 times 2 times, I could change this to 2 times 5, that would be better. But anyway, I only have one pair of numbers here. So 40 simplifies to 2 times the square root of 10. And that's my answer. Okay, the next one, I'm solving again. I'm solving for a leg because I have the hypotenuse. So, and they give me radical numbers here. So when I square anything that's under the radical just goes away. Okay, so I'm going to end up with, and then I take the square root, x squared equals 4, so obviously x equals 2. Okay, so don't get confused when there's radicals here. When you square that, the radical just goes away. Number 8 is similar. I'm still solving for a leg. So I want to set up my equation. I get x squared equals 88, so x is the square root of 88, and then I have to simplify that. So on this one, I just started by dividing by 2, so I get 2 times 44. I can keep dividing. I get 2 times 22. 22 then simplifies to 2 times 11, which doesn't simplify anymore to a perfect square. So I take out the 2, and I'm left with 2 root 22. So these next problems, I need to find the missing side length. These are special right triangles, right? The first 4 here, those are 30, 60, 90 triangles. And then the last ones are 45, 45, 90 triangles. So I need to go back to my patterns over here on the sheet. So if I'm going to do the first ones first, 30, 60, 90, remember the short leg is across from 30 degrees. The long leg is across from 60 degrees and is equal to the short leg times root 3. And then the hypotenuse is the short leg times 2. So if I can use that pattern in how I set up these problems, it's really not too bad. So remember, I always want to work back to the short leg. So if this is 60 degrees, this is my long leg, and my short leg is across from 30 degrees. So this is the short leg. And they gave me the hypotenuse. So I know that the hypotenuse is equal to the short leg times 2. So 18, and they call it b here, is 2b. So 18 divided by 2, b equals 9. And now I always remember, we always go back to the short leg first, and then I'm going to multiply the short leg times the square root of 3 to get the long leg. So the long leg is equal to the short leg times square root of 3. So the long leg here, A, is equal to the short leg times root 3. This is 9. This is 9 root 3. And the hypotenuse is short leg times 2. So for all these problems, I'm going to set it up exactly the same way. So in this case, again, I was given the hypotenuse. So this works very similarly. So I'm going to work back to the short leg. So V is equal to the hypotenuse divided by 2. Or if I want to write it the same way I just did, let's do that. Let's say the hypotenuse is equal to V times 2. So the hypotenuse is 12. Divide by 2, so I get V equals 6. And I would write it on your triangle there. And then I know to get to the long leg is equal to the short leg times root 3. So the long leg, U, is equal to 6 root 3. And those are my answers. Okay, so this problem actually is pretty straightforward because they give us the short leg to start with. These are the easiest kind of problems. So you just take your short leg times root 3 to get to the long leg. So I get 2 root 3 for the long leg. And then 2 times 2, I get 4 for the hypotenuse. Over here, now they're giving me the long leg, right? So this one's a little bit harder. So I need to get from the long leg back to the short leg, and then I'll work and get the hypotenuse. So since I have the long leg, and we know the long leg is equal to the short leg times root 3, just plug in my values. So I have 7 is equal to the short leg is y, root 3. So in this case, I have to divide by root 3. So I get 7 divided by root 3 for y, but I can't leave it like that because I need to rationalize the denominator. So I end up getting 7 root 3 all over 3. So when you start with a whole number in the long leg across from 60 degrees, you will always end up getting something over 3 You divide by 3, multiply by root 3. So I'm going to get 7 divided by 3 times root 3 in my answer. So don't get confused when the short leg actually has the root 3 in it. You always have to look at your angle first to see what the relationship is there in the triangle. Okay, so these last problems are 45, 45, 90. So as soon as I see one 45 degrees, I know they both have to be 45, and these legs have to be congruent. So a lot of people think these are easier problems. If that's 5, the other leg is 5, and the hypotenuse, so this is a leg, I don't have short or long, they're equal, so leg, and then hypotenuse, again, is always across from the 90 degrees, so the hypotenuse is equal to the leg times root 2. So if the leg is 5, then the hypotenuse x is equal to 5 root 2. In this case, don't get confused because they're giving you root 2 as the leg, but this is the leg, that's a leg, and that's the hypotenuse. So you will definitely have something like this on a quiz because they're going to try to trick you, right? So let's do the easy one first. So if this leg is root 2, this leg has to be root 2. Oops, root 2, so y equals root 2. And then the hypotenuse is equal to the leg times root 2. So the hypotenuse, x, is equal to root 2 times root 2, which is the square root of 4, or you can think of it as the radical goes away, but you get x equals 2. So don't get confused when they give you a whole number as a leg, a radical for the leg instead of a whole number for the leg. The root 2 is not always going to be in the place of the hypotenuse. In this case, they're giving you a hypotenuse, and we have to work backwards. So again, since it's 45 degrees, I know A and B have to be equal. So I know that the hypotenuse is equal to the leg times root 2. So the leg then is equal to the hypotenuse divided by root 2. So that's 10. And B also equals 10. And then don't get confused or all befuzzled when they give you a fraction with a radical, and we have to figure that out. So again, just start by labeling your sides. So we have a leg, and a hypotenuse. And then my hypotenuse, A, is going to be the leg times root 2, right? Leg times root 2. It's always that way with a 45, 45, 90 degree triangle. So the hypotenuse, A, is equal to 9 times the square root of 10 all over 10, times the square root of 2. So when I multiply what's under my radical, I'm going to get 9 times the square root of 20 all over 10. Well, careful, because now I need to simplify the square root of 20, right? So the square root of 20 is 4 times 5, so 2 times 2 times 5. So if the square root of 20 ends up being 2 root 5. So when I take out 2 root 5, I need to multiply it by the 9 that was there. So 9 times 2 root 5, I get 18 root 5 all over 10. And then careful, because I need to simplify these numbers that are outside in front of the radical. So both are divisible by 10, so I get 9 root 5 over 5. Okay, these next 4 problems are what we call walk-around problems. And so what that means is it's just a multi-step problem. So I need to figure out one side of a triangle in order to get to another part of a second triangle. So in this case, I'm going to start here because it's a 30, 60, 90 triangle. So they gave me the long leg. I need to work back to get the short leg. So since they gave me, remember the long leg is equal to the short leg times root 3. So if I say the long leg, 9, is equal to the short leg, I'm going to get 9 divided by root 3, but I can't leave it like that. So I get 9 root 3 all over 3, and that's going to simplify to 3 root 3. A lot of work over here. 3 root 3 to get the short leg, right? I'm not finished yet. What I need to do is get over here to the hypotenuse. So the hypotenuse, remember, is the short leg times 2. So 2 times 3 root 3, I get 6 root 3. And that's the hypotenuse. And now I'm going to work back from the hypotenuse in a 45, 45, 90 triangle. So I have the hypotenuse, and I need to get back to the leg. So on my second triangle, remember the hypotenuse is equal to the leg times the square root of 2. So I'm just going to plug in 6 root 3 is the hypotenuse, is equal to the leg, in this case x, root 2. So I'm going to divide by root 2. And then I can't leave this radical here, so I have to multiply by root 2 over root 2. And then I'm going to simplify that, so I get 3 root 6. So then finally, these problems, the application problems, you just need to draw a picture, but it's all using the same skills that we have. So anytime you have an equilateral triangle problem, remember that's always going to turn into two 30, 60, 90 triangles. So when I draw the equilateral triangle, all of the angles are 60 degrees. So when I draw the height here, that divides the top angle into 30 degrees and 30 degrees. So I'm left with a 30, 60, 90 triangle here, where this is the long leg, or I'm sorry, this is the hypotenuse, hypotenuse. This is the height, is the long leg, and across from the 30 degrees is the short leg. So if this is 16, the short leg is just 8, and that makes sense because this part would have to be 8, right? Because I'm dividing it into 2 triangles. And then, so what I really need is the height of the triangle in order to find the area, because the area of a triangle is 1/2 times the base times the height. Well, the base is just 16. All 3 sides of the triangle, the equilateral triangle, are 16. So the whole base of the triangle is 16, and then the height is what I'm missing. So the height is the long leg of the 30, 60, 90 triangle. So remember, the long leg is equal to the short leg times root 3. So that's the height right here, the height. So the long leg, and then I'm just going to multiply. So since I would take care of that first, 16 divided by 2, so I get 8. 8 times 8, root 3. So 8 times 8 is 64, root 3. And then, don't forget, when you have word problems, you need to have units. And since it's area, it's square units. 64 root 3 inches squared. The next one, we have a square has the area of 49 square centimeters. So the area of a square is side times side. They're equal, right? Because it's a square. So the square root of 49 is 7. That's how I get the sides of the square. And a square breaks into 2 45, 45, 90 triangles. So since this is a 45, 45, 90 triangle, the diagonal is the leg times root 2. 7 root 2, and I have 2 diagonals. I'm supposed to find the sum of the diagonals. So the other diagonal would also be 7 root 2. Sorry, 2 times 7 root 2 is equal to 14 root 2. And again, since it's a word problem, we need units. So the sum is 7 root 2 plus 7 root 2, or 2 times 7 root 2. It gives me 14 root 2 centimeters. On all these, you really need to draw a picture. So I have a 12-foot ladder rests against the house at an angle of 60 degrees with the ground. So this is the ground, obviously. What is the height? So I'm looking for this right here. Well, that's the long leg of my 30, 60, 90 triangle, right? So they gave me the hypotenuse. So I need to work back and find this is, even though I didn't draw it to scale here, the short leg is just 6. 12 divided by 2 is 6. So the long leg is 6 times root 3. 6 root 3. And again, we need feet. 6 root 3 feet. Easy peasy once you draw it. Okay, 45, 45, 90 triangle has a height of 10 inches. What is the perimeter of the triangle? So if it's a triangle like this, where it's a height of 10 inches, both legs would be 10. And since it's 45, 45, 90, I know that the hypotenuse is 10 root 2. So the perimeter, I'm going to add around the sides. So 10 plus 10 plus 10 root 2. I can only combine these, so I end up with 20 plus 10 root 2 inches. And perimeter, I don't square. I just have regular linear inches here, right? And then lastly, an equilateral triangle has a height of 9 inches. Find the area and the perimeter. So first thing, we have to draw a picture. This is the 60 degrees. Just like our problem above, it's going to divide into two 30, 60, 90 triangles. The height of the triangle is the long leg, right? So I need to first work back and get the short leg. So the long leg is equal to the short leg times root 3. So I end up with the short leg is 3 root 3. Multiply that by 2 to get the hypotenuse. And then remember, because it's an equilateral triangle, all of my sides are 6 root 3. Right? This whole thing would be 3 root 3. This would be 3 root 3. So the whole thing is 6 root 3. So then I can do my area. So area is 1/2 base times height. So base is 6 root 3 times height of 9. I get 27 root 3 square inches. And the perimeter, I have 3 sides that are all 6 root 3. So 3 times 6 root 3 is 18 root 3, or add up all 3 sides. 6 root 3 plus 6 root 3 plus 6 root 3, I get 18 root 3 inches. And that's it. So just make sure that you draw a picture on these kinds of problems and label your triangles. And remember, with the 30, 60, 90 triangles, always start by finding the short side first.